Okay, I'd like to talk to you about the drill press. This is a fairly large pedestal drill, meaning it's on a pedestal, and we use it constantly for drilling vertical holes and being able to control the drilling of whatever we're doing. So the drill, the business end of the drill is known as a chuck, and the chuck on this drill is a particularly good one. It can even, despite the size, it can even hold a 1mm bit, which not many this size can do. It's also known as what's called a keyless chuck, meaning that you don't require any kind of key to lock it. You simply open up the chuck so that by turning it this way, so that the bit will fit, rotate it back the other way, which brings the jaws of the chuck down and onto the shaft of the drill bit. And simply by just turning it like that, that's it, it's in there. You know, you can grab this ring at the top and you can squeeze it as hard as you like, but it's not going to make any difference, it's in. And then to release it, it's just a matter of turn it back the other way slightly. In fact, you can do that, just give it a quick turn and the drill bit will come out. So that's all that's involved in putting a drill into the drill bit. So if you're using a smaller drill bit, there is a possibility that as you wind the jaws of the chuck down, you can get it caught slightly off to one side. I'll exaggerate it. So that now when it turns, I'll just switch it on, you can see that the bit's not straight. Now that's quite exaggerated, but for smaller bits, it's quite possible that they can get caught. It's important when you're putting a drill bit in, I spin it in my fingers to make sure that just as it tightens up, it's vertical. And now it spins correctly. So just be aware of that with smaller drill bits. Make sure they're straight before you start drilling a hole. That's the chuck. There's an on-off switch up here, and pressed in is off, up is on. Now you'll notice that I've turned it on, but the machine's not running. The reason it's not running is because a lot of the time we like to be able to hold things with one hand and drill with the other. And it's hard to do that and turn the switch on at the same time. And so we've incorporated into this drill a foot switch, which is down here on the floor. And once the drill has been turned on, just by putting your foot on the switch, activates the drill. It's a switch that you have to keep your foot on to keep it going. The moment you take your foot off, it turns off. It's not a press on, press off. Keep your foot on it, take your foot off. So sometimes you might come in here and wonder why the switch isn't working. It's because the foot switch is in there. The other thing I'd like to talk about is that this is a variable speed drill. And so along the side of the machine there's a lever with a big black knob on it, and there's various speed settings from 280 up to 2600. For the majority of drilling operations, we just leave it somewhere in the middle, around 900 is fine. There are occasions when we use it at high speed. We seldom ever use it at much lower speeds. So in order to change the speed, the machine has to be running. You can't do it with the machine not running. But you loosen this knob and move the lever back to where you want it to be, and then tighten the knob back up. I'll demonstrate that with it running. So it changes speed quite readily, particularly it wants to go flat out, that's where it wants to be. The issue that you need to be aware of is that if you come in here to drill a hole in something, you really don't want to be doing it at 2600 RPM, you really only want to be drilling it around about the 900 mark. And so it pays to be aware of how fast the machine's running when you come in. If you come in to drill something and you turn it on, it may not be immediately obvious, but if it looks like it's going too fast, check where this lever is. Someone may have left it in the high speed position. I'm just going to move it back now to where our normal drilling operations are. It's important that that knob is done up tight, otherwise it'll come loose, it'll fall off and it'll just go out and run it flat out. On the side of the chuck there's a depth stop system. There's two nuts that can be screwed up and down to act as a depth stop. We use it some of the time, not a lot of the time. So there are two spanners hanging on a hook on the wall, and it's just simply a matter of loosening these off. Hopefully a gorilla didn't do them up beforehand, and these can be raised and lowered to set your depth. Next thing I want to demonstrate is that well, first of all, the table can be raised and lowered depending on, you know, how thick or deep the piece that you're wanting to drill through is. In order to raise and lower it, there's a locking screw at the back here that needs to be just loosened off, and on the other side of the pedestal there's a winder, and you can wind it up and wind it down. You'll notice what I'm doing is I'm actually supporting the weight. There's a cast iron table under here which is very heavy, and it just hangs on this whole mechanism. So if you try and wind it, you know, it's really hard, but if you support the weight, it makes it much easier to raise and lower it. And then once it's in position, simply lock the bolt off and hold it there. Another thing I like to do is avoid drilling into the table itself. You can see that happens, and occasionally I fill that. But the idea is to put a sacrificial piece of wood under whatever you're drilling and set the drill press up so that the drill is going to stop before it hits the table. So I'm going to drill a hole in my piece of wood. I'll put a sacrificial piece underneath. I've checked that the bit will get to and touch the wood. It won't go through and hit my table. I've got a mark on my wood. That's where I want my hole to be. I want it to be exactly on that mark. So these bits, which are called braid point bits, are absolutely ideal for drilling in timber. That's what they're made for. You can see it's got a very sharp tip, and it has two very sharp cutting points on either side. That drills a very clean, neat hole in wood, as opposed to a normal twist drill bit which are made for drilling into metal. And you'll notice that needle point tip allows you to position it with great accuracy, so you can make sure that you're right on that X. Now I'm holding it so that the point is just touching in the wood, but the cutting corners of the bit are not touching. So I want to keep it there so that nothing moves. I'm holding the piece with my left hand, and I'm going to start the machine and start drilling. Before I start drilling down, I'm going to get the machine running before it touches the wood. This is important because otherwise it'll tear the wood out and possibly throw the piece of wood at you. Starting the machine. Now I start drilling. And we now have a very clean, perfectly positioned hole, and we haven't drilled into our table. One thing you might have also noticed is that sometimes when you're drilling, you need to pull up a little bit to help clear the cuttings out of the hole. Now, one thing I must emphasise is if you come all the way out of the hole, don't just plunge straight back into them. So if nothing moves, it's not a problem, but if it moves ever so slightly, you're going to tear out the side of your hole. My strong recommendation is if you come out of the hole, wait for the machine to stop, then place the drill bit back in the hole, make sure it's in there, and then you start again. And complete drilling the hole. Okay, while we're at the drill press, I'd just like to talk briefly about one of the jigs that we use routinely with the drill press. And that's this gadget, which we use for drilling the dots, the little holes for the dots, the fret marker dots on the side of a fretboard. Here's a fretboard that doesn't have any dots on it. And it gets placed on this jig, and it sits at the back here. And there's an inclined surface which keeps the top edge of this horizontal. That's then clamped to this fence, and the jig itself is then clamped to the table. So that's really what I want to talk about. On the underside of the jig are 2 aluminium tracks, and on either side of the table are two T-bolts with nuts, securing nuts underneath. They get loosened off and till the end of the T-bolt goes into the track, and we do the same at the other end. And now the jig can be manoeuvred backwards and forwards until the drill bit that we're using lines up perfectly with the centre line of the fretboard. Now there's no drill bit in there at the moment. We're not here to demonstrate how the jig works. What's important to know is that this then gets tightened down with these 2 securing bolts, and then the jig just is simply used to slide the fretboard east-west, and it always remains centred under the chuck of the drill. When you've finished, this is then removed by loosening these 2 bolts up and simply sliding it off and putting it back where it belongs. But before you leave the room, what's vitally important is that these 2 bolts get tightened up so that they're not left loose and rattling, because if they are, the nuts fall off, the star nuts fall off, and we lose them. So we make sure that they get tightened up, and they're not going to fall off while the drill's being used.